now our next talk will be a virtual talk by Arti Ahluwalia alongside Carmelo de Maria Arti, who heads the Ubora Association. The association manages the Ubora platform for collaborative design of safe, open medical technology. We are incredibly excited to have her share her virtual talk named Ubora Platform Collaborative Design of Safe, Certifiable Medical Devices for Health Equity.
Hello everyone, my name is Arti Ahluwalia and I'm going to talk to you about the Ubora platform for collaborative design of safe, certifiable medical devices for health equity. So I'll start off with a little bit of background. Nearly 20 years ago, when I was much younger, I was funded by the EU, the European Union, to help develop core competencies in biomedical engineering and clinical engineering in the Philippines and Indonesia. This project was focused on developing teaching courses at university level for biomedical engineers in these two countries, because it was recognized then in Asia that there was a lack of capacity in these areas, and this was holding back development in healthcare systems. Thanks to this work, I was invited by the United Nations Economic Commission for Africa to a summer school that they had funded on developing biomedical education programs in African universities, because they recognized that health in the system, health in the countries, is a way towards wealth in the countries. There were many like-minded people at this summer school, and together we decided to create what's now called the African Biomedical Engineering Consortium, which is a consortium of African universities which work together to harmonize quality education in biomedical engineering as a method of developing a new professional healthcare sector for improving healthcare outcomes in Africa. Thanks to this, we got together with the ABEC team to apply for funding again from the European Union to create a virtual platform for the co-design of open source medical devices to address these global healthcare challenges, the lack of equity in healthcare across the globe. And the platform is now managed by the Ubora Association. So what is Ubora? Well, it is a platform, as I mentioned. It's a virtual infrastructure, and it's also the community that manages and uses the platform. And it's for helping people co-design open source medical device technologies, focusing on the safety of the devices right from the beginning. So safety and efficacy are two key words in our philosophy. So medical devices, as you all know, are intended to prevent diseases, diagnosis, and they're also used as support systems for people who are unwell. And they can be very, very simple, or they can also be very complex and very invasive, but they must all be safe and effective. And it's really important that we deliver safe and effective quality medical devices, high technology ones as well, to everybody in the world. This is one of the UN Sustainable Healthcare Goals, equitable healthcare, through access to quality instrumentation, which is now used all over the world by doctors. They rely on quality instrumentation. There is a problem, though, in low middle income settings or low resource settings, because a lot of the equipment is generally donated. Very little is purchased on site, but in fact most of it ends up in what's known as donation junkyards, because people don't know how to use them or to maintain and repair them. So the problem is not just the lack of money, but it's also the lack of expertise, lack of sufficient staff who know how to run and manage the equipment. There is also a problem of lack of spare parts, and also the lack of reliable electricity and running water, most of these devices are actually made and designed in countries where everything runs perfectly, and then they come to be used in situations where it might not be so. So these challenges could be addressed by using an open source approach. So that is developing methodologies where you share the source code and design specifications, and you also allow people to distribute and modify, and also by enhancing local production, so local materials, using local capacity to make and repair, and definitely through targeted training programs, because quite often in low resource settings, there's not, as I mentioned, adequately trained staff. There isn't sufficient capacity. One of the challenges of applying this type of approach in low income settings or developing countries is that the regulatory framework that people normally use is the European one. It's a very well-known regulatory framework, which sometimes is not really strictly and directly applicable in low resource contexts. One could develop solutions through the frugal innovation methodology, and this is one of the key concepts in the Ubora platform. So the Ubora platform can be reached using this link here. So when you go to this link, you sign up to the platform, and you come into the Ubora system, which basically operates within the first steps of the life cycle of a medical device, which is where most of the costs are centered. So developing medical devices is actually very, very costly. And a sharing approach, as well as an open source approach, could substantially reduce these costs. We do focus very much, as I mentioned, on safety by design, and so the platform also has expert mentors who contribute to the design process. So we empower collaboration and we stress safety right from the start. You go onto the platform, it's divided into different areas, different tabs. So the first one is clinical needs, and then the development of the projects, different resources for supply of materials, for example, and then there is the community that you can refer to for expertise, and then there are various administration tools that the management group might need. So the clinical needs is probably the most important and the most innovative part of the platform. So this is the one where people try to identify needs by coming together as a community. So it's both engineers and clinicians as well as patients. And then we have the part of project management, which is the management of the different devices that one might come up with in the initial needs through the initial needs process. And then you go through a device classification process, which you classify using a decision tree with 30 different questions, and that helps people classify their devices and thereby be able to understand which are the standards and the regulations that they need to use in order to be able to develop and then implement their biomedical device. You go through then the phases of concept design, and prototyping, step by step, so you get followed through, and obviously at all steps of the process you can access expert opinions and people who know about medical devices and know also about teaching and design. And then finally, we've got the process of the pages or the packages of implementation, operation, and finally the project closer process, which involves actual development for manufacture and sale. There are also many resources, as I mentioned. So Ubora is generally very widely used as a teaching material, both within Europe and Africa. And so we have slides, handout notes, etc. We have several tutorials and building process documentation that students in classes can follow through. There's also a user manual and a development manual. And then, as I mentioned, there is a large community of over 500 users, 400 to 500 users, growing continuously. I just wanted to mention some of the success stories that have come out of Ubora. So a couple of companies have adopted our open source automatic defibrillator within Italy and within Europe. There is a solar power autoclave. There is a baby warmer that has been sold now in Uganda. There are walking frames, for example, in carbon fiber, which can be used for the elderly, which are very low cost and very light. And these are completely open source and can be easily used and distributed anywhere where they're necessary. The other success story that I mentioned is the automatic external defibrillator, which is a class 3 medical device compared with the first one. And this one is now currently being marketed in Italy and within Europe. So this medical device was developed completely using the Ubora platform. The other success story that I should mention is also Palbrest, which is a bra used for breast examination. And this is a completely wearable and safe class 2 medical device, which can be used instead of self-examination, which many women tend not to do for lack of confidence. Ubora has also been very successful in its outcomes. So apart from the development or the setup of ABEC, we've also been able to gain funding for a biomedical engineering mobility program across Africa, where staff and students were exchanged, and also ABEC and ABEC came together to develop a common core curriculum, university curriculum in biomedical engineering. Another important outcome of the Ubora project is a new project which has recently been funded by the Italian government, which is called the Afya Moja project, which means One Health in Swahili, and it promotes the shift from capacity building to capacity strengthening by working together. So not just building new capacity, but also building on strengths that African people and African countries definitely have, but of which are not valorized. The project actually spans across 4 disciplines, not just biomedical engineering, but it also encompasses medicine, veterinary medicine, as well as agriculture and nutrition. So the Ubora platform is still going strong, and I do invite you to go and have a look at it. And I'd like to thank you very much for your attention.